Thank you very much. I'm not sure if it's fortunately or unfortunately, but you'll tell me by the end. My name is Rodrigo, and for the next, let's say, roughly 40 minutes, we will talk about itertools. Now, why would we talk about itertools? There's roughly 200 modules in the standard library, so why am I talking about this one? Well, because I am obsessed with it, and it is my talk, so that's why I picked this one. But because there's practical reasons. There's practical reasons that make itertools such a useful module. And by the way, I forgot this disclaimer. This is a small enough room that if you have any questions in the middle of the presentation, just shout them out. I'll repeat them for the sake of the recording, but we can take care of it there and then. I think it's best if we do that instead of just letting the questions pile up for the end, because then we will lose the context. So if you do have a question, feel free to just shout. All right, so then I do have a question for you. I have two snippets of code on screen. You can see range of 10 and also range of a gazillion. And the question is, which of these runs faster? Yeah, it's roughly the same. It might take a nanosecond longer to parse the gazillion, but the truth of the fact is that these two ranges run in about the same amount of time. And why is that if the gazillion is so much larger than the number 10? Because range, the built-in range, generates elements on demand. Right? It's generating the items as needed, as opposed to something like a list that would hold all of the elements in memory. So this makes it so that you don't really have to worry upfront with everything you will need, with all the numbers you will need, as long as you know how to produce those. Now, can I get a brave volunteer that doesn't even need to get up? Can I just get someone to interact with me for a second? All you need is to count. So does anyone know how to count? OK, would you be OK with interacting with me for a second? Thank you so much. So I'm going to ask you to count to a gazillion, all right? But wait. No, not right now. You only give me a number when I ask you for it, all right? So can you give me the first number? OK, that's debatable, but let's go with... I wasn't specific enough. Yeah, fair enough. All right, so let the recording show that... what's your name, my friend? Enrique said 0. Now, can you give me the second number? Enrique said 1. Can you give me the next one? And Enrique said 2. Can you give me the next one? And we could go on and on and on, and 40 minutes wouldn't be enough. And notice how when I asked someone to count to a gazillion, Enrique was fine with it, with the idea that eventually we would get to a gazillion, but Enrique didn't have to write down like all of the numbers beforehand. That's what the list would do, quote unquote, whereas range just produces them on demand. You ask for the next number, you get the next number. So that's why the two ranges I showed before took roughly the same time. And the key idea that I want you to get from this is that laziness is a good thing in these types of situations. You specify what you want to compute, a way to compute it, but you don't do the actual computations until they're needed. And that's what the built-in range does, that's what the built-in zip does, that's what the built-in enumerate does, and that's what generators, in general, do. And if you don't know generators, that's fine, but it's something I really recommend you go and learn about, because generators can make your code infinitely faster. Like the potential upside is infinite. In practice, it's never infinite, but the potential is infinite. And all of this to say that lazy iterables are awesome. So range is awesome, zip is awesome, enumerate is awesome, generators are awesome. And the whole point of the talk, the module itertools loves these iterables. It loves all iterables equally, but lazy iterables in particular, because it's easy to work with lists. You can index them, you can sum them, you can slice them, but you can't do those things with zip or with enumerate or with iterables in general. And that's where itertools comes in. Itertools has a lot of tools that allow you to work with these iterables in an efficient and, let's say, idiomatic and easy way. I forgot, was it the easy or the simple? Because there was a talk here yesterday about the easy versus simple. It was easy, yeah, we want easy. Do we want this? Yeah, of course, yeah, because it's the complex. Okay, yeah, so this is simple, not necessarily easy because you have to learn it, and it's just easier, exactly, it's just easier to grab lists because they're there, but it ends up being simpler. So let's take a look at the menu of what itertools has to offer. But before we do that, just a quick content warning. There's 20 names in the module itertools. There's 20 things you can import. And the point of this talk is not for you to memorize every single one of them. Like I said in the beginning, I'm obsessed with this topic. I don't know if I could list all 20. I could get maybe 17, 18, if you gave me enough time. I can't list all of them on the spot. So the point is not, please memorize everything. The point is, I'm going to show you some tools. I want you to get acquainted with the things you can do with itertools so that the next time you need them, you kind of go, wait, what was the guy talking about? There was something that did something similar. And you just open the docs and you look for it. So this is just to help you trigger the idea of, oh, wait, I can reach out to itertools. But don't memorize the whole thing, please don't. So this is everything there's inside itertools, or at least the public stuff. It's a bit messy, even though it's ordered alphabetically and neatly aligned, because I have issues. So let's mess this up, and let's rearrange things. I like rearranging the 20 names in itertools like this, because it gives me 5 categories of things I can think about. And the way I would maybe be able to list 17, 18 of the things in itertools would be by going through these 5 categories, because I'm not sure if you noticed, but 5 is way less than 20. And I know that 19 of those go in the 5 buckets, and then there's T in the corner. But fine, no one cares. There's these 5 main categories. And the combinatorial iterables, these you would typically associate with mathematics and the shuffling things around and grouping things and whatever. But what I will show you, I do have a maths background and I like maths. And I know folks tend to either love it or hate it. If you love it, awesome, we can be friends. If you hate it, we can still be friends. I'll try to make it so that you understand that these are not necessarily for maths only. There's the reshaping iterables that will accept, sorry, I keep saying iterables. An iterable is just something you can go through. It's something you can plug into a for loop, right? Like a string or a list or a tuple or even a dictionary actually, or a file, things you can put in a for loop and go through from one end onwards. That's what I mean when we talk about iterables. You can think of it as a stream of data. Yeah? Awesome. And these reshaping iterables, they take this stream of data, they don't modify the elements themselves, but they change the way the data is formatted. So it might group the data somehow, it might shuffle a couple of things around. That's the point of these reshaping iterables. These infinite iterables will accept a small amount of data, and they will create infinite streams of data with the data you provided. And in practice, infinity is not very fun to work with, but the point is not, you don't want to go through these until infinity. Eventually you will stop, you just don't know when. And you will see, I'll show you a couple of examples of when these ideas are useful. The filtering iterables, I guess it kind of goes without saying. The point is you have a stream of data and you only want to pick some elements from that stream. So this is what the filtering iterables are good for. And then, when I was done, or when I was thinking about this categorization, I was left with 3 things. And then I was like, what do I call these? And thankfully enough, I figured out a way of just giving a common name to all of them. These 3, they're the odd ones out, but also 3 tools that complement other tools that we already have. I know this is super vague, but from the names of star map and zip longest, maybe you can get a clue. So we will take a look at those later. So now let's get started. Let's take a look at some combinatorial iterables. Again, don't memorize the whole thing. Maybe if you let me scroll down, not scroll down, but go back a couple of slides. This might be the most important slide, so you can take a picture or not, it's fine. this is like the categorization. That's the most important thing I would say. Now we'll just take a look at a couple of these from each category. So I'll wait a second for the picture.
What about T?
What about T? We'll figure it out later, don't worry. Great. Let's move on. I'm going to fast forward again. Sorry. 1, 2, 3, 4, 5, 6. So combinatorial iterables. Let's start with combinations because why not? I really like ice cream. In general, if it's unhealthy, I like it. And sometimes I think, well, there's these 3 flavors of ice cream. I've got chocolate, vanilla, and strawberry. Like, if I were to have an ice cream with 2 of these flavors, how many different ice creams could I have? Do you understand the question? So I don't mean to insult anyone's intelligence. I'm just, because if you understand the question, then you understand the solution, because that's what combinations does. It takes some pieces of data and figures out how to combine them in different ways without repetition. And therefore, if you were to run the code shown on the screen, computing these 2-element combinations of the flavors of ice cream, you get 3 different ice creams. Chocolate and strawberry, chocolate and vanilla, or vanilla and strawberry. And the order here isn't important. Now, when the order is important, you might want to take a look at permutations. So permutations will tell you in how many different ways you can order things. So say I have the same 3 flavors of ice cream. Just for the record, I don't really like vanilla ice cream, but I put it there because it's, well, vanilla. So you've got chocolate, vanilla, and strawberry. In how many ways can you serve a cone with these 2 flavors? And the cone here is important because the flavor that goes on the bottom is the one you have last. So usually I prefer to have the one I like the most on the bottom. So it makes a difference, the order. And if you ask this question, well, there's 6 ways in which you can order 2 different flavors. Chocolate can go on the bottom, and then you can have either vanilla or strawberry on top, or the other 4. So that's the idea of permutations. And these might still feel a bit mathy, and truth be told, the examples are a bit mathy, even though they're based on ice cream. But product, which is the one I'm going for now, is the one that I'll most easily convince you of that it's useful outside of maths. So first, what does this do? Well, I feel like having either 2 or 3 scoops of ice cream, I'm not sure yet, and typically you can choose between a cup or a cone. So how many different orders could I make? And now what you need to do is you need to pair each possible different number of scoops with each possible different container. And that's what product does. You give it 2 or more sources of data, and it's going to combine everything together to figure out all of the different ways to mix things up. So you get 4 different orders, either 2 scoops on cup or cone, or 3 scoops on cup or cone. Now, how is this useful outside of maths? Take a look at the nested for loop on the screen. Note how the 2 statements, the 2 for loops, are independent from one another. The first iterable has nothing to do with the second one, but you need to go through both. And inside the loops, you're essentially combining all values from one iterable with all values from the second iterable. And that's exactly what product does. So this saves you 1 level of nesting. And on the screen, this wasn't a lot because you had 3 lines of code, now you have 2. You had 2 levels of nesting, now you have 1. But if you're in a class that has a method, that has a context manager, that has a conditional statement, that has 3 loops, then nesting suddenly becomes a lot more important. And if you get acquainted with the idea of combining the streams of data, then you look at product and you immediately recognize what's going on. It's the nested for loop. So this is a pattern you can easily apply because nested for loops are fairly common. There would be another combinatorial iterable, but let's not talk about it now, just for the sake of your patience, honestly. So now let's take a look at a couple of reshaping iterables. And maybe my favorite one, chain. What does chain do? Well, it's not, you're not chained as in stuck to the place. It will let you chain things as in put them together. If you have 2, 3, 4, 5, 6 lists and you need to go through all of them, you can sum them together, right? Because you can add lists, and what happens is you get a result with all of the elements of all of the lists combined. But when you do this operation, you're creating a new list. So you're spending some time to create this list and to move the elements into the list or the references, depending on what the objects are. You're creating more stuff. But the whole point of the operation is for you to go through everything. You don't really require the final list. And if you don't care about the actual list, you just care about going through everything, then just use chain. Because chain will let you go through 2 or more iterables in sequence without actually spending the time to create this final master, main, larger iterable you can go through. And I'm talking about lists because these are easily understood and you can sum them, but some iterables you can't even sum them together. If you try to sum 2 zips together, you can't. If you try to sum 2 enumerates together, you can't. So sometimes you can't even sum them together, and this is the only way of going through all of those in sequence. And if you run the code on the screen, so if you have 3 lists with the numbers 1 to 3, and then a list with the number 4, and then a list with the numbers 5 and 6, if you chain the 3 lists together, then you can easily go through all 6 numbers. Will these 3 lists show up in your code? Of course not. Will this idea show up in your code? Well, absolutely yes. Going through 2 or more iterables is fairly common. If you want later, I can show you a, what was it? For example, a pull request on CPython, where using chain sped up an operation on the module pathlib by a lot. Because you needed to go through 2 different sets of paths, and they were appending the lists. And it feels like such a basic thing, and the lists are not that very long. But using chain instead of the sum actually sped up that code by like 30% or something. I don't remember, I might be lying about the numbers. But it made it faster. So it's also a nice performance optimization. And what I really like about chain is that not only can you chain these things together if you have multiple iterables, but also, please be seated for this, if you have an iterable of iterables and you want to go through the second level of depth, you can use chain.from iterable. If you have a list of lists, you go through the elements of the sublists. If you have a list of files, you go through all of the lines in the file. If you have a list of strings, you go through all of the characters in those strings. This is very nice. Why is no one applauding? Thank you, thank you. This was all me, yes.
Question on the chain then, is it also possible to perform operations on the iterables and use chain for sorting without having to make a new list? So that, for instance, you can do chain sorted lists.
All right, can you use chain? Let me summarize the question if I got it right. Can you use chain on iterables that were operated on? Well, flash news, folks, if you have an iterable and you sort it, the result is an iterable. So you can, because in the end it's still the same thing. A list or a sorted list for chain is just an iterable. Chain doesn't care. So yes, you can do whatever you want as long as you pass iterables to chain. They might be lists, sorted lists, they might be zips, enumerates, whatever you want. Does that make sense? Great. Okay, so then you already applauded, thank you very much. Then let's take a look at iSlice. You can list, no, wrong way around, I was about to say you can list slices. Let's flip that. You can slice lists, you can slice strings if you want a substring or a sublist. In general, you cannot slice iterables. So not all things that you can go through can be sliced. For example, files cannot be sliced to get just a certain range of lines. But with iSlice, and the I doesn't stand for Apple, for the Apple products, it stands for, I think, iterator, either iterator or iterable, I don't know. It allows you to slice iterables. Of course, you have a bit less freedom, because with list slices you can go completely crazy. You can do a step that's negative, and then reversing is the same as doing the -1 at the end. iSlice has a bit more restrictions because iterables are not that general. You don't have that much freedom, but they do allow you to slice things. So as an example, I like playing this battleship game where you have like a 10 by 10 area where you place some battleships, and then you have to try and guess where your opponent placed the battleships. And I was creating this grid to create this small game, and I used product. It's not foreshadowing, it's backshadowing, if that's a thing. I used product, wink, wink, to figure out all of the coordinates of the board, and then I wanted to print a couple of them. And my instinct would be to slice things, but you cannot slice a product. But what you can do is you can iSlice the product. So this is an example of using iSlice. Now that I think of it, it's a bit redundant because we've already talked about slicing and you know what slicing is, but this is what it looks like. You give it the thing to slice, and either when to stop or how many elements to ignore in the beginning so it starts a bit later, so you can do those sorts of things. Although you cannot reverse, so you can't have a negative step. This is iSlice, and another one I really like, I'm going to say that for all of the tools, is pairwise, which is fairly recent. Is it Python 3.12 maybe? 3.10? I don't know. It's fairly recent, and it replaces a pattern that I thought was super common, but last time I checked wasn't. So wait, I updated this slide. No. Oh, only the next one. Sorry. So let's look at this one. I have a list with 3 strings, hello from Prague, and I want to combine strings 2 by 2. I want to create pairs of adjacent strings. And the way I would do this before was, or I would use zip, and then I slice the list to remove the first element, so that I create like this shift, and then in zipping, I'm misaligning the lists, and I get the pairs of adjacent strings. And I thought, has anyone ever done something like this? A couple of timid hands in the air. All right, this is the pattern. What's the problem with this? Although it's easy, because you can, the slice with a 1 colon is kind of, you get used to reading that as, okay, skip the first, or the colon -1, you get used as reading that as, okay, skip the last. This is creating 2 extra lists, because slicing creates copies, so you're spending time creating copies you don't really care about. There's no point in moving data around in creating more lists. So this is what pairwise fixes. You get the exact same results, but without spending all of the time shuffling data around and creating new containers for stuff. Yeah, no need for that. So this is pairwise. And as a challenge for you folks, how would you implement this without this technique? Because the slicing only works for things that can be sliced, right? So as a challenge, homework for you, how would you implement pairwise? And then if you come up with a solution, feel free to ping me on Discord or anything, and I'll be happy to chat about it. Sorry, you're there. Sorry, what?
Does this have a parameter which allows like
If I can use pairwise to create, instead of pairs of elements, triples of elements, or quadruples or whatnot, no. It's your second homework. How would you generalize this? Because it's a very interesting exercise, it really is. All right, now on to these infinite generators, or iterables, apologies, they're not generators. On to these infinite iterables that sound kind of weird, because why would you need infinite things? And again, the point is not it goes to infinity, the point is it goes as long as you need it to. And that's the key idea. Now this one is kind of like what Enrique was doing, except you don't need a human next to you. It's just on the code. You can use it to count from 0, so you were correct, up to whatever. And an example use case would be, for example, for an ID generator, because you want to start at maybe 0 or not, maybe you want to start at 1, and then you just want to increment it continuously. And you don't know beforehand how many beers you'll drink. You know you'll drink some, but you don't know how many. So you just create this counter, and it goes on and on and on. Now, cycle slightly more interesting. Maybe yeah, let's not compare usefulness, but it's a bit more interesting because instead of just counting, you need to give it something to feed the cycle. Now, question for you, have you ever had something like a list, bless you, and you wanted to go through the list, and when you got to the end, you wanted to restart, and then you got to the end and you wanted to restart, and then you end up either crying or using the modulo operator to do some neat modular arithmetics to go to the big. Have you done this? Can I get just a hands up? I see some nods, but okay, so it's fairly common, awesome. I'm not the only weird one. Well, you don't need the module, you can just use cycle. For example, if you have a bunch of chicken-related words, if you cycle through them, and if I were to run the code as shown with only the cycle in the for loop, what would I get? An infinite amount of chicken, chicken, egg, chicken, chicken. Because, again, cycle is infinite. So you wouldn't use cycle like this just by itself, but you would maybe zip it with something else, or in this particular case, I can just slice through it and I get a sentence with 8 words. Chicken, chicken, egg, chicken, 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 egg. Right? Now, is iSlice the best? I just keep doubting myself. I don't think iSlice is the best pedagogical example. I tend to use cycle with a zip. For example, say you have a bunch of numbers. This is very weird, but it's slightly closer to the actual usage. You have some integers, say a range, and you want to say whether each number is even or odd. And instead of having an if statement to check the parity, you can just zip the numbers with the cycle of even and odd. And so those things just keep on repeating, right? 3 is odd, 4 is even, 5 is odd, 6 is even. And notice how one of the streams advances with some purpose, and cycle just keeps on repeating even, odd, even, odd, even, odd, even, odd, even, odd, even, odd. Yeah. And now I'm just going to reformat the code a little bit so that instead of the for loop, I have a join. And the reason I show this here is to remember myself that these tools from the module itertools and the built-ins that work on iterables and lots of other things, honestly, they're highly composable. And one thing I really like about these is that once you start using them, once you get used to them, you start seeing the patterns that each tool is useful for, and you start combining them. And right now, I will show a couple more combinations of these itertools, and they will look weird and unnecessary and maybe bad code. But the truth is, if you start using itertools, if you start getting used to itertools, if you start learning about it, you'll think to yourself, how did I live without this? So don't reject something just because you have to learn it, because that's, if you weren't supposed to use it, it wouldn't be there. The standard library is there for you to learn about it. Of course, if this is your first day learning about Python, I won't show you iSlice or cycle, of course. But if you've been doing this for a while, just learn about it, because it will make your code simpler. Just I doubted myself there for a second. Great, and the final infinite iterable, they were just 3, so we can go through all of them. Repeat just takes a piece of data and just repeats it. Excellent. So you could give the talk yourself. Like this, it goes on forever. I had fun doing this by hand, I'll confess. It just goes on forever, but you can say, okay, let's just do it 3 times. And you get proc, 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 if you just repeat proc 3 times. But then again, you can combine these things together. What if you zip the years 2023, 2024, and 2025 with the repeat of proc? Now you can create a sentence or a piece of output that says that EuroPython 2023 was in Prague, and so 24 and 25, all right? And now you're combining them. And now what if you actually want to go further back and you want to think of 2021 and 2022? 2021 happened online and 2022 happened in Dublin, so you put those in a list. But then you have the repeat, you can't really sum them, so you chain the 2 together. And now let's not do the range because, honestly, let's go back 1 slide. When I look at the range of 2023 with 2026, it takes me a second to remember that 2026 is not included. So then maybe just count from 2021. And now you zip. And now all of a sudden you have, 4, different iterables, zip is built in 3 from the module itertools. And yet the output makes perfect sense. I got carried away there. Yeah, would I actually write this code? Maybe, I'm kind of weird. But maybe if you use just 2 instead of 4, it would still be an improvement. All right, and I think it's the final category, if I know how to count, which I usually don't. Let's talk about filtering iterables. Again, this is personal opinion, I'm very, very sad that I don't get to use these as much as I'd like. Drop while and take while, they're really neat because they kind of do the opposite. So they go really well together, it's really fun. And compress is so weird. Come ask me about it later because I have a whole, yeah, let's not go there. So let's just talk about filter false and compare it with filter, which is a built-in. Do you still use filter from time to time, or do you just use, okay? And now, do you just use list comprehensions instead of filter? Okay, so the folks with their hands up, please keep them just for 10 more seconds. Are you, what was the question? Put your hands down. Right, so if you use list comprehensions instead of filter, is that like an ideological thing? I'm not judging, I'm just asking. All right, so I think filter is still useful, sometimes. I love list comprehensions, also obsessed about them. I have way too many unhealthy obsessions, but filter is still useful. Suppose you have a list with some tuples, so a list of pieces of data, and you have this function that I will call a predicate that computes a Boolean value for each piece of data. And this would be a class, and I would format it in 2 lines, but I don't have a lot of space on my slides. So that's why the function is crammed together. But let's say you have this function, and it's important that it is a function that computes a predicate. If you already have the predicate, it's much easier to use filter. Well, not easier. Actually, also easier. It's both easier and simpler to use filter, because the filter takes the predicate and the stream of data, and the code that's on the screen, the loop that goes through this filtering only produces the names of the people who are adults, which in this case would be N. I'm glad someone is still awake. And in contrast, if you use filter false instead of filter, who can guess what you get? Harry and George, you get the opposite. If you didn't have filter false, you would either need a lambda with the function and the not, or a list comprehension with the if at the end with the not. And again, I'm not against list comprehensions, I love them. I wrote like a whole book on them. That's how obsessed I am. But there's still place for filter and filter false. Oh, again, I said I couldn't count. And then there's these 3 complementary tools. They were kind of the odd ones out when I was trying to figure out how to group them. But again, they're nice because they all complement something else. Accumulate goes with reduce from the module functools. Star map goes with map from the built-ins. And zip longest goes with zip. Excellent. So let's take a look at zip longest because it tends to be the one that's most useful, or more commonly useful. If you have 2 or more streams of data, 2 or more iterables, that may or may not have different lengths, if you zip them together, zip stops at the shortest one. This is zip's behavior. From 3.12 onward, is it 3.12? I keep forgetting. I don't know. Fairly recent, zip now has a keyword argument called strict. You can set it to true if the iterables are supposed to have the same length. And if they turn out to not have the same length, zip will error. So turn on strict equals true if they are supposed to be the same length. But that's going to stop always at the shortest one. Zip longest goes until the longest one. And by default, for the iterables that are done already, you get the value none. So you get Harry 17, N 21, and George none. But you can also specify a fill value that lets you use a different value to fill in the missing data. So suddenly George is now 99. So we've gone through the 5 sections the 5 categories that I presented, and then we're left with T in the corner, which you so kindly pointed out in the beginning. And if you can see in the back, I'm sorry, but there's T in the corner, in the bottom right corner. So yeah, let's talk about T, but let's do it maybe next year. Because T is nice, it's very useful, but also very niche. And we could have like a whole talk just on T. So looking back at everything we took a look at, highlighted on the screen are the iterables that you've seen examples of. We looked at filter false, permutations, product, and combinations. We looked at count, cycle, repeat, zip longest, and also chain, islice, and pairwise. My favorite 3, I would say, are product, chain, and pairwise. Folks tend to like zip longest as well. Don't memorize the whole thing, that's not the point. And just to shine some light on the things we did not cover, there's also some great things here. I'm personally a fan of group by. You can do all sorts of weird stuff with group by. It's so much fun. And also T in the corner. Don't forget T, because T is nice. I'll give you a hint. You may want to use T for the pairwise exercise. It's not strictly needed, but it might be a good idea. So now the final question remains. So how do you take this and how do you write good code with it? And the only answer I know of is go and write bad code with it. What I personally do when I learn a new tool is I try to cram it into whatever code I'm writing. I try to come up with all sorts of weird usages of it. And I don't know yet if it's going to be a good idea or a bad idea. I just force it in there. And by doing this in a bunch of different situations, I kind of like this. Now this is terrible. Okay, I like this idea. Oh, wait, I can do this? All right, and what if? And through experimentation and through combining, you start to realize how things combine together, how things compose together. And that's the only way I know of figuring out how to write code. You know, I learn a new syntax feature, I learn a new tool, and I just abuse it, go crazy. And then eventually I come to the realization, okay, I like these patterns, I don't like these patterns. So that's my advice for you. That was the advice. Now I just have an ask. This QR code will take you to a Google Forms where you can fill in a short, I already said it's a form, where you can give some feedback about this talk. And once you do, so I'm gatekeeping, once you do once you do fill it in, you get a link to a blog article that contains example usages of all of the tools. So we only covered some. The link will contain all of those. And I mean, if you don't care, that's fine. The documentation is excellent. You can just go straight to the documentation. So that's what I have for now. I appreciate your time, and I'm up for any questions you might have. Thank you.
Thank you so much, Rodrigo. And any questions? So personally, examples with ice cream will be popping up every time I'm wondering it. Yes, you're welcome to come up closer to the microphone that our online visitors also can hear you really well.
So first, thanks for a great demonstration of content of the itertools. I would like to ask about the performance. Is all the items or all the content or all the functions that are present done via generator? Or, for instance, you presented there is a list, yeah, or you chain multiple lists. Yeah? When you use the chain on the lists themselves, is it done like a generator, or is it performance good, or it is still the list of lists somehow chained? Thank you.
Everything in the module itertools is done with laziness in mind. So with the example you gave about chain, if you chain a bunch of lists, the idea, so it's strictly speaking, it's not a generator, but it's exactly the same idea. So you get the performance boost of not doing the concatenation, the not creating a new list, and you get, for all tools in the module itertools, you get an infinite potential upside because everything is lazy. For example, filter false, we saw filter false. It will not do any filtering until you ask it to do, and when you ask, it only does just enough to give you the next value. You saw count. Your computer doesn't explode if you instantiate count. Count will only produce numbers as required, and it's an infinite generator. So there's always infinite potential upside. In practice, it's not infinite. It's a 2 times speed up, a 10 times speed up, a 1,000 times speed up. You have to benchmark it. I hope that answers. Great.
All right. I can just hand.
Thanks, great talk. I'm also obsessed with iterables and everything around it, but sometimes in practice, it happens that when you use it too often, even though it's beneficial, and you start returning generators and iterables, and you inadvertently exhaust them, down the road somewhere, you might end up with quite nasty errors. So I have seen in a code review that I received that, well, it's a lot better to go with a list here and return it instead of going with the iterator itself. My question is, how do you resolve these issues? Like, are there any use cases in your practice when you literally go for straight list because you don't want to have some iterable or generator floating around because it might get exhausted? Thanks.
All right, thanks for the question. So there's one thing that's very important from what you said. Maybe it was not your most important point for you, but one thing that's important for folks listening is these things from the module itertools, these tools produce one-off iterables. So to be even more technical about it, they produce iterators. So you can only go once through them. For example, you saw count. Count is going in one direction, it's going up, and that's it. And that's the same thing for everything else. So if you do the zip longest thingy, once you're done, you're done. There's no way to go back. So if you need to go through the same iterable twice or more, itertools is a bad idea. Great. And then the balance between, then you're just asking about the balance between simple and easy. And I would say go talk to Hinek. I don't know. I often go for easy things. If I open the REPL for a quick calculation, I'll probably use a list or 2 lists, and I'll just sum them up because no one is watching. Yeah, you do get interesting error messages, or it becomes a bit harder to debug if you do have a bunch of generators and itertool stuff going on chained together. But that's the price you pay for the elegance, for the simplicity. Everything is a trade-off. I love answering questions without answering them. But yes, that's what I would say, yeah.
And we have time for one more little question.
It's
All right, maybe
someone I think just, mustered up the courage.
I used to love writing Ruby, kind of like this.
I'm sorry.
No, this is what Ruby's best at, so don't, yeah. But then somebody who had just come from another language said, you could just use much more basic things in the language, and then everybody would be able to understand this more easily and read it very fast. And that's the whole Golang philosophy. How do you fight that war in a PR?
How do I fight
or
what?
Don't
Sorry?
fight it.
No, what was the fight? How do I fight that?
How do you fight that war in the PR comments?
Well, good question. It's again, give me 10 seconds. Again, I think it's a matter of simplicity versus easiness, and it's going to depend a lot on your context. I'm coming up with a random example that might not be true, but just the idea. If you're writing code in a team of scientists who are not computer scientists, and you're just writing some code because you need to get stuff done, and folks around you have very diverse levels of understanding of Python, and you just need to get stuff done. Maybe you don't have to be very fierce defending itertools. Maybe just go with the for loop, fine, or the least, okay. But if you're writing professional code and if the standards are high, why not go for the things that do the thing you need? I'm going to scroll through slides very quickly. If you look at accumulate, you don't need anything else for that matter. You don't need accumulate. Just write a for loop with an accumulator variable. What's your problem? Well, my problem is that accumulate does it in 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. I don't know how to, I think 9 characters. And the for loop is going to take me at least 1 line to initialize the variable, 1 line for the for loop, 1 line for the update, bare minimum 3 lines, usually more. And its meaning is accumulate. So why not use the thing that has the name that does the thing? Yeah, of course, everyone reading Python knows a for loop, but accumulate is the idea you're looking for. So it's much more idiomatic.
All right, thank you so much. So let's give a big shout out to Rodrigo and